Okay. So now we will discuss. We have seen capacity outage table. So the next logical step is finding out loss of load indices. Now remember that in the whole of reliability engineering or power system reliability, this is the most important concept. So any research paper you are going to study for your thesis, so many times you will find this terms. Even in the modern papers relating to microgrid reliability or microgrid operation, you will find all this thing. So understanding this is very essential for going ahead in the domain of reliability. It is also applicable for small scale power systems, isolated power systems and so on. Okay. Loss of load indices. Making it loss of load indices. So this is the reliability index. So what we have seen the capacity outage table. Okay. We have seen the capacity outage table. So capacity outage table is nothing but the generation system model, or you can say the generation system reliability model. Generation system reliability model. So this can be converted with appropriate load model. So we need to get some load model so as to produce a system risk index, which are, so these are of two kinds: loss of load indices and loss of energy indices. Okay. Now this load model you can have two kinds. One is chronological load. What is chronological load? That means hour 1, hour 2, hour 3, every hour the load is there, one after another. The other type of load is known as using load duration curves. Using load duration curves. Okay, load duration we will see in detail in the further slides. The simplest load model and the one very extensively used one is where each day is represented by daily peak load. So, see in this case we are not plotting the load curve. Rather, we are interested in the peak load because our objective is the whether the peak load will be met or not. It is not about energy here. It is about whether the peak load will be met or not. So you can have, yes, it is written here. So you can have daily peak load variation curve, chronological, or you can have load duration curve. What is load duration curve? We will see. So the term capacity outage indicates a loss of generation which may or may not result in a loss of load. If the capacity outage is not resulting in any loss of load, doesn't matter. We are not interested in that. We will only see the probability. So whenever loss of load occurs, the loss of load occurs only when the generating capacity is in service exceeded by the system load. This you want to write it. So write this part. A loss of load occurs. A loss of load occurs only when the generating capacity in service is exceeded by the system load. Okay, in service, the generating capacity in service is exceeded by the system load. Clear? Now come to the index. So what is the index? The index is known as loss of load expectations. So what is the loss of load index? It is the expected number of days in a specified period in which the daily peak load will exceed the available capacity. The peak load will exceed the available capacity and hence loss of load will occur. So write down this formula. So this is generally asked in the 2-mark question. So what is the formula for loss of load indices? So loss of load expectation is given by probability of capacity being less than the load. Probability of capacity being less than the load. Okay, and it is the unit is days per year, days per month. Okay, depending on the requirement. So days per year. So these many days per year, the loss of total occurs. So as you know, for a very good power system, it should be points 0.01, 0.05 like that. Okay, where Ci is the available capacity on AI, Li is the forecasted peak load on that day. Okay, we are making an estimate. So it is the forecast. So Pi is the probability of load on AI. The value is obtained directly from the capacity outage cumulative probability table. So for computing LOLE, the first step required is for computing LOLE, the first step required is to prepare the capacity outage table. Okay. So when you write this formula, this is very important. So when you go to the Excel sheet to compute the LOLE, you need to know this formula. Okay. This is the example we want to consider. This problem is a recurring problem which you will see in various models, including the distribution system here. So this is a typical system. So this is that non-identical unit system. So you have got two 25 megawatt unit and one 50 megawatt unit. Okay. So how to build the capacity outage table? First you will build the capacity outage using only two 25 megawatt units. Okay. Next you will build the capacity of 50 megawatt as in service or out of service. Okay. Then you will convert both together. So it is exactly similar to that 2 3 megawatt and 1 5 megawatt system. Only the capacity outage value will change. Okay. Now this failure rate and repair rate are not important for this case. This we will see in module 2. Okay, when we discuss frequency and duration approach, we will see this. FOR for all the cases is 0.0. Remember that there are two approaches of genetic capacity reliability evaluation. Okay, one is the probabilistic approach. Okay, one is the probabilistic approach where you read the FOR. The other one is the frequency and duration approach where you need to know the failure rate and the repair rate. Okay, so here we have been given simple daily load variation. Okay, so in 365 days, we have daily peak load 57 megawatt occurs for 12 times. Daily peak load of 52 megawatt occurs for 83 times. Daily peak load of 46 megawatt occurs for 107 times. 41 megawatt 116 times. 34 megawatt 47 times. If you add this up, this should add up to 365. Right? Because it is for 365 days. Okay. Compute the loss of load expectation. Okay. So we will go before going to the Excel sheet. First you need to prepare the COD. Okay. So following that 2 3 megawatt and 1 5 megawatt, complete the COD. Prepare the COD. Just follow yesterday's class work. Probabilities will be exactly same, only the capacities will change. Okay. Okay, do it yourself by checking your class. First you have to make 2 megawatt, 225 megawatt. Then you have to make 150 megawatt as in service, out of service. Do it. Yes. So this is the system. This is exactly same as those two 3 megawatt and one 5 megawatt system. Only this capacity values are changed. Okay. So if you see here, what are the capacity values? 0, 25, 50, 75, 100. 0, 25, 50, 75, 100. So write down this. So how you prepare it? First, you prepare for only 225 megawatt. So either unit 0 is out, or 1 is out, or 2 is out. In that case, the capacity out is 0, 25, and 50. Now that work this way: 50 megawatt in service, 50 megawatt out of service. When 50 megawatt is in service, then in this case, if available capacity is 50 megawatt, 75 megawatt, and 100 megawatt. Similarly, 50 megawatt out of service, this is only 50 megawatt. This will be 0 megawatt. Okay. Now 50 megawatt in service. Okay. It is in service. So what is the total capacity in service? 0 plus 50. What is the total capacity in service? 25 plus 50. And this will be 50 plus 100 megawatt. Okay. So this is the available. Now 50 megawatt out of service. So it is 0. Okay. So capacity outage. In this case, capacity outage is 0. No, I made a mistake here. 0. Capacity outage is 0. That means how much is available?
100.
50.
50 plus
50. So capacity outage is 25. That means how much is available? 25. 75. Capacity outage is 50. But 50 megawatt is there. So 0 plus 50. Right? Similarly here, 50 megawatt out of service. That means 0 megawatt available. But 50 megawatt is also out of service. So 0 plus 0. 75 megawatt. Okay. Here, yes. Here 50 megawatt unit is out of service.
50
is out of service.
But
That's why it is 50. That's why it is 50.
yes, sir. But the place is
So available is 0. Actually 0. Here 50 plus 25.
25 plus 0.
So it will be available is 0 plus 25.
sir available sir 0 only sir. Sir 50 टा only out of service अछि ना से दिटा तो चली छी 25 megawatts रो दिटा चली
Yes, it is 50. Very good. Yes, it is 50 megawatt.
the
50 megawatt is 25 megawatt and this is
0.
0 megawatt. Okay. So total should add up to 100. Anyway. Okay, total because capacity of the system is 100 megawatt. So total in the end should add up to 100. Okay. And this is exactly similar to COT. Then we multiply 0.98 and 0.02. So here we multiply 0.98 okay, to get this value, and here we multiply 0.02 okay, to all these three to get these three values. Okay, that as we discussed yesterday. Okay. So the final COT is this. The final COT is this. Did you write it down? Write down the final COT. Okay. Now remember that these values are exactly similar to that 2-3 megawatt and 1 megawatt system. Yes.
Sir, हमारा जो यूनिट सर्विस रे अछि और यूनिट आउट ऑफ सर्विस रे अछि बोथ केसेस सर दीटा कंडीशन अछि कैपेसिटी आउट 50 और कैपेसिटी मेगावाट अवेलेबल 50 बट सर बोथ रे डिफरेंट अछि प्रोबेबिलिटी.
Which one? This one?
Yes sir, that one I understand though.
This one?
Yes sir, and that
This is 50 megawatt out of service.
Yes, sir.
But out of this 225 megawatt, there are 225 megawatts also.
Yes.
So none is out.
Oh.
So available capacity is 50.
Yes, sir.
Now the question is, here none is out. Okay. The probability is 0.9604. Now what is the probability of 50 megawatt out of service? 0.02. So this probability should be 0.9604. This one into 0.02. Is it?
Yes.
Multiply this and you should get
But
it.
sir, at the addition of 50 megawatt unit in service, there will be another 50 capacity out and another 50 megawatt available in the last line. In
Yeah.
service, 50 megawatt in unit in service, you can see that there is 150 megawatt capacity out and along with capacity megawatt available.
Here 50 megawatt is out. Here 50 megawatt is in service.
Yes, sir, but
This is the 50 megawatt unit in service. Okay. 50 megawatt unit in service. So it is not out. So outage is 0 out for the 50 megawatt case. But for this 225 megawatts also the outage is 0. Okay.
what's the last line?
This one.
Yes, sir.
So in this case, 225 megawatts are out. 50 megawatt. But this 50 megawatt is in service. So available capacity is 50.
Yes, sir.
Okay. So what is the probability? Probability will be this one, point equal to 4 into 0.98. Okay.
But sir, in our COT for the system,
Which will be this one. Okay.
yes, sir. But we are taking only the. We are adding both.
Which one? Oh, for this case you are saying. Oh, I am telling you. This individual probability for 50 megawatt which is equal to, there are two 50 megawatt cases, right? One is this or this. This or this. Right? So available capacity is 50 megawatt, outage is 50 megawatt for this or this. That means you will add up this plus this. Okay. For example, if I see here, you see it is K12 plus K15. Check here. K12 K12 plus K15. So K12 is which one? This one. K12 is this. Okay. Then K15 is this. So this is the summation of K12 and K15. What generally is this? Because there are two states. So we add it up. So either this happens or this happens. Both cannot happen. You can say that 50 megawatt, 20 megawatt also out of service, also in service. Not possible. So either this or this. And I have told you several times, the probability when there is or, it is plus, when there is and, it is multiplication. So and case you will see in interconnected systems. Okay, where multiplication will be there. Okay. So did you write this with the cumulative probability? Write it. Done. Now this is the COD. Okay, so here one new thing we learned, where there are two states of the same capacity, you need to add up the probability. Okay. Now let's see how the LOLE or loss of load probability is computed. So this is the COT. So for this system, what is the loss of load probability? How to compute? So the formula was summation
of
probability of Ci minus Pi. Li. Ci minus Li. So what is the load in this system? Okay. As per the given question, peak loads are given and their occurrences are given. Number of occurrences. Okay. The peak load and the number of occurrences are given. Okay. Now what is the load?
load is 100 megawatt.
These are the loads. Peak load means these are the loads. So what is Ci minus Li? Capacity is 100, total capacity is 100. In all the cases, total capacity is 100. Now Li is, load is this, so Ci minus Li is, these are the probabilities. Now how to obtain this probability? How to obtain this probability of Ci minus Li? Okay. Now this you have to get from the capacity output statement. From the cumulative probability. I have told you because, for example, since the load is 57 megawatt, since the peak load is 57 megawatt, loss of load will occur if the capacity outage is 43 or more. Okay, so I can write here, for this case, loss of load will occur if the outage is greater than or equal to 43 megawatt. Okay, because our load is 57, so if just at 43 megawatt the loss of load will start. But just it will beat the load. If the outage is 43, so your available capacity is 57 and it will just meet the load. But if the outage is more than 43, then loss of load will occur. So in this case, we'll see here, okay, megawatt outage. So our case, outage should be how much? 43 megawatt or higher. 43 megawatt or higher. So it lies somewhere between 25 to 50. Okay. So we take the next one. This one. Okay. Because we cannot say 25. In that case, this will happen. This is for capacity outage 25 or more. This cumulative probability is capacity outage 25 or more. This is capacity outage 50 or more. Our requirement is only 43 or more, but still we will take for the 50 as a conservative measure. So the corresponding value here is, as you say, 0.2039. Okay, from there. Similarly, in the next case, the peak load is 52 megawatt. So what is the outage so that the load will be just met? That is 45, 48 megawatt, 150. Now, if the outage is more than 48, it cannot meet the system demand. The capacity outage cannot meet the system demand. Now, 48 again falls here. 48 again falls in this band. So, we will take again 0.02039. In the third case, the peak load is 46 megawatt. Okay? Peak load is 46 megawatt. Outage required is 54 megawatt for loss of load. 54 megawatt and more. Just 54 megawatt it will meet the load. Just meet the load. But 54 megawatt and more. So 54 comes here in this band. So we will take this one. 00079. Similarly for 59 megawatt outage, 66 megawatt outage, the same. Okay? Because both fall within 50 to 75. Okay? Now, our requirement is we should add up these probabilities to get LOLE. LOLE is the summation of these probabilities. LOLE is the summation of these probabilities. But then, every instance occurs for 12 times, 83 times, 107 times, 116 times, 47 times. Since this summation is there, so we will simply multiply this number of occurrences with
the probability of CA minus L.
probability. Number of occurrences. So now we will make. Okay. Now since loss of load probability is equal to summation of probability of capacity outage, but in this case each outage occurs a particular number of times, we will simply multiply this. Okay, to get this. That means if you multiply 12 with this, you should get 0.24474. Okay, like that. So you can see here. So it is T6 into V6. T6 number of occurrences into V6 probability. T7 into V7, T8 into V8, T9 into V9, T10 into V10. Okay, and you add this up. So this is the summation of W6 to W10. Okay, so this many days per year. Okay, so this is the answer for this system. So for this system, you have 2.15 days per year of loss of load expectations for this particular system. So this is how it is calculated. Okay. So we stop here.